Hey there, Seahawks. It's Miss Adams, and in this video, we're going to have an introduction to statistics and talk about categorical data. All right, so what are data? Data are values along with their context. Data can be numbers or labels. The W and H. So in order to determine the context of the data, consider the W's. Who, what, when, where, why, and how. So who are the cases about whom the data was collected? People are referred to as respondents, subjects, or participants. Who does not always imply people. What and in what units are variables that are recorded about each individual. These can either be categorical or quantitative. When is when the data was collected, not when the data was used. Sometimes there's a big difference in the amount of time that's gone by between when it was collected versus when it was studied or used. Where the data was collected, why helps us to determine if the data should be treated as categorical or quantitative, and how was the data collected. The how piece will become a lot more important in future lessons. All right, two types of variables. A qualitative variable is used to answer questions about how cases fall into categories. This may be comprised of word labels or numbers as labels. So some examples would be color, sex, type, zip code. So these are our categorical variables or qualitative. A quantitative variable is used to answer questions about the quantity of what is being measured. These are comprised of numerical values. So some examples could be height, weight, dollar amount, size, test scores. All right, our first example, are the numbers 17, 21, 44, and 76 data? All right, the answer here is no, because data must have context. These are just digits. All right, another example. A report on the Boston Marathon listed each runner's sex, country, age, and time. Identify the following. So the who would be Boston Marathon runners. What are the variables that we're measuring? So sex, country, age, and time. When was not specified. We don't know. Where would be Boston, Massachusetts. Why is the race result reporting? Most likely the reason why we're getting this. How it was not specified. We're assuming we got most of this information from registration info and then the results. The categorical variables here would be the sex and the country. The quantitative variable would be their age in years, and the time in hours, minutes, and seconds. All right, the number one rule for data analysis is make a picture. All right, one way you can do this is using frequency tables. So this helps us to organize counts by recording the totals and the category names. All right, so I know it's not so much like very picture-y, but it still helps a lot. And find the proportions, percent, frequency, and relative frequency of sophomores. All right, so we have this table and we have totals. So as a proportion, there's 534 sophomores, 10th graders. Out of the total here, when I added them up, was 1,601. All right, and I can change that to a decimal. It's 0.3335. As a percent, it'd be 33.35%. Remember, when you go from a decimal to a percent, you move it 2 places. The decimal point, move it 2 places to the right. Frequency is just the count. So there was 534 sophomores. And relative frequency is in percentage form. So 33.35% were sophomores. All right. Categorical distributions, we can display them using a bar chart. Okay, so this first one is this is a relative frequency bar graph or bar chart because it has percentages on the y-axis. The other one would just be a frequency bar graph or bar chart. Notice that there are spaces between the bars, and on the x-axis we have categorical data. 9th grade, 10th grade, 11th grade, 12th grade. Yes, they're numerical, but they're putting them into a group, 9th grade. Okay, so they're in really a category. All right, another type of display for categorical data or qualitative data are pie charts. All right, so make sure to use labels and percentages when you're making a pie chart. A contingency table or a two-way table is very much like our frequency table, just has the totals, those margins. So identify the row variable, the column variable, the total, which we put the total, we call it n, the number of cells, and then the totals. So our row variable here would be sex, either male or female. Our column variable is grade level, freshman, sophomore, junior, or senior. Our total is in the bottom right corner. Number of cells are 8. And then the totals are in the margins, like the total number of males, total number of sophomores. Those are in the margins. All right, let's take a look at this example. So we have 2 hospitals. So we have a hospital choice, and then we have survival outcome. They either died or survived. They were either in hospital A or hospital B. I'm going to go ahead and fill in the totals here by adding across or down. And then what percent of people died? So the probability notation is going to be capital P, and then in parentheses, what it is I'm measuring. So probability that they died is equal to the total number that died, which was 79, out of the table total, which is 2,900. So I'm going to change that to a decimal. Remember, fractions just mean division, divide, get your answer. We're going to get 2.72% died. What percent of people were from hospital A? So this would be the probability that they're from A is equal to the total number from A, 2,100, divided by the total, the table total of 2,900, gives me 0.7241 or 72.41% from hospital A. The next one is a little bit different. Amongst those that survived, so that means out of the ones that survived, what percent of patients were from hospital B? So the notation here is going to be the probability that they're from B given, this vertical line here, is given they survived. So out of those that survived, okay? So how many were from B and survived was 784. They were from hospital B and they also survived. Out of those that survived, given they survived. So 784 out of 2,821 works out to be 27.79%. All right, 2 types of distributions for categorical variables. So a marginal distribution, how to make it, we're going to convert totals into percentages. So hair color versus sex. So we have males and females, and then we have brown, blonde, black, red, and then we have our totals in the margins. So find the marginal distribution for the hair color variable. So this is out of the hair colors. All right, so for brown, I had 46 total in the margins for brown out of the table total 136. All right, so a marginal distribution, you're taking the total in the margin and you're dividing it by the table total. All right, so this is for hair color, so I'm going down at the bottoms of each column. All right, 46 out of 136 gives me 33.82%. For blonde, I had 59 out of 136, which would be 43.38%. Black would be 22 out of 136, which is 16.18%. Red is 9 out of 136, which works out to be 6.62%. Then find the marginal distribution for the sex variable. Okay, so male and female. I'm looking at the total for males. There's a total of 63 males out of the table total 136. So 63 out of 136 is 46.32%. For females, the total was 73 out of the table total 136, which is 53.68%. All right, now I can use that data to make a picture. So I'm going to make a bar chart. So brown, I just went up to those percentages and filled them in. Okay. The other one, this is relative frequency by sex, male and female. You have to be cautious because if you notice, it looks like there's a huge difference between male and female. When I looked at the percentages, they weren't that far off. Okay. So the reason that one looks so staggering is because the graph does not start at 0. Okay, so if you're going to make a picture, make sure that you're counting by the same number each time on your y-axis, and also that you start at 0. All right, the second one would be conditional distributions. So we look at one variable, then look at each value of that variable, then break down each value into its pieces, and we always use percent. So using the same table, find the conditional distribution of the hair color variable. So for male and female, brown, blonde, black, and red, I'm going to do for male brown, I'm going to do, this is for hair color, so this is out of the hair color totals. There's 26 males with brown hair out of 46 total that have brown hair. So 56.52% of brown hair is made up of by males. Blonde, 24 males had blonde hair out of 59 total blondes. That's 40.68%. 10 males had black hair out of 22 total with black hair, which is 45.45%. 3 males had red hair out of 9 total redheads, which is 33.33%. All right, I'm going to do the same thing for females. So brown hair for females was 20 out of 46 total. Brunettes, 43.48. 35 total females had blonde hair out of 59 total blondes, which is 59.32%. Black, 12 out of 22, and red, 6 out of 9. All right. All right, so I can do the same conditional distribution based off sex. So I'm going to do males. There's a total of 63 males, so I'm going to break down each hair color divided by the total number of males. So brown is 26 out of 63, blonde 24 out of 63, black 10 out of 63, and red 3 out of 63. Okay, so out of the males, I could see that 41.27% of males have brown hair. So we can see the distribution within the group of males. And then I could do the same thing for females. So brown, 20 out of 73 total females, 35 out of 73, 12 out of 73, and 6 out of 73. So I can see the breakdown there, and you can notice like the difference between brunettes in the male group versus female group. We could also represent this data visually, so we can do a segmented or a stacked bar graph. So each bar would be 100%. The values of the variables are on the x-axis, and the bars are segmented into parts of each value. Okay, so we could do it by hair color, so brown, blonde, black, red, and then you can break that down into, out of that group, which proportion or which part of it is male versus female, so you can kind of see like a visual size comparison. You could also do it by sex, male and female, and then do the different hair colors. All right, so that kind of shows you a little bit. You can see some of the differences nicer in the pictures. Another possibility is a mosaic plot. This allows us to see the group's size by scaling on the x-axis. And this is one categorical variable with multiple groups. Okay, so you can see like this time it makes a difference because the category for blonde is larger because there's more blondes. Or in the one where it's by sex, you can see that the female group is a little bit larger because there are more females. Okay, so it kind of actually takes up the area principle, like this amount of space matches the amount of people. All right. You could also do a side-by-side bar graph. This allows us to see the differences side by side. All right, go Seahawks.